today we're going to talk about extrema. There's two types of extrema on graphs. There's absolute, or there is relative, or also known as local. Extrema is pretty much when there is a turning point. So the definition is up here. They're extreme values. They are either maximums or minimums. Sometimes it's absolute, which means it's the biggest possible, or the smallest possible, depending if you're looking at a maximum or a minimum. So for this first graph right here, just looking at this graph between x equals -5 to 5. The smallest point on this graph, the lowest point, is going to be right here. So the absolute minimum is going to be, and whenever I ask for the minimum, I always ask for the y value, unless I'm asking for the point. So the y value, absolute minimum, is going to be -145. That's the absolute minimum. Absolute maximum is the highest point, and in this case, it's right here at 44. So again, minimum is right here, -5, -145. Make sure you answer on the y values. Same thing with the maximum, answer on the y values. Okay, unless it asks for a point specifically or the x value. So absolute extrema can happen at two different places. It actually happened up here. It can always happen at our endpoints, or it can happen at our turning points. And so right here, I have two endpoints and two turning points. Or turning points. So I don't really like using the word turning points. I like to just say that it's going to be extrema. So anytime I say the word extrema, you can just think turning point. Okay, so let's look at this graph right here. So I'm going to go through this. Relative, again, means that it could be absolute, or it could just be locally a max or a min. So I'm just looking for when it is a little hill or a little valley. It could be the lowest or it could be the highest, but it's going to be extrema. The relative maximum minimums cannot be endpoints. It has to be actual extrema. So for these, it must be extrema. Absolute, that's when this can be endpoints or extrema. Relative has to be all of your extrema. So the absolute minimum here is going to be -42. I'm just going to write out the point, though, for you. Let's just say that all these I want points. Okay? Absolute maximum. It's actually right here at the point -239. Relative minimum, that's when, so we don't look at the endpoints anymore, just look at extrema. So there's extrema here and here. So because it goes from decreasing to increasing, that's going to be a relative minimum. Relative maximum is going to go from increasing to decreasing, which happens right here. So I'm going to get -2, 39. If you notice, my relative max and my absolute max happen to be the same. Not always the case, but it is in this. So relative extrema can only occur at turning points. Again, I'm going to stop using that terminology in just a moment. Okay, so this is pretty much everything with graphs. We're going to get to just functions. I think it's a little bit simpler to understand just doing the functions. So here we go. So finding critical numbers. Critical numbers are just extrema. Okay? If it's when 2 points here. It really is going to be when the derivative is equal to 0, or if the derivative is undefined. So any of those two are good. You're going to get critical points from that. So these right here, that's a critical point, and that's a critical point, because if you notice, their derivative is equal to 0. I can draw a horizontal tangent line at these places. So that's what critical points are, when I can draw horizontal tangents. So let's find the critical numbers on example 1. So what we have to do is find the derivative. So the derivative in this case is going to be, well, just these two use power rule. 4x to the third minus 16x. Okay? We're going to set this equal to 0 and solve. So we're just solving like we would back in Algebra 1 here. So these have a GCF of 4x. So I'm going to get x squared minus 4. And then this factors further. So I'm going to get x plus 2, x minus 2 equals 0. Set each of these equal to 0. And I'm going to get critical numbers, by the way. These want numbers, not points. So my critical numbers are x equals 0 and plus and minus 2. I do not need to plug this back in. I just wanted numbers. Did not want actual points. So these are where your critical value is going to happen. At x equals 0, at plus and minus 2, that's where it's going to happen. Okay? So that's how you find critical numbers. Now determine the critical points. This is different. This I actually want points, like a comma b, so whatever that happens to be. So let's go ahead and do that. So g prime, and we're going to set this equal to 0. We're going to get 6x squared plus 6x minus 12. And then we're going to set it equal to 0. It says a GCF of 6. So I'm going to get x squared plus x minus 2. And then this is going to factor further, which is going to be, let's see, I'm going to have a 2 and a 1. This is going to be a plus 2 and a minus 1. So kind of ignore that 6 because I can just divide that over and get rid of it. So set each of these equal to 0, and I'm going to get x equals negative 2 and 1. Now I need to plug these back in to get my actual points. So I need to know what g of negative 2 is and what g of 1 is. And that'll help give me my y values. So when I plug this in, I'm going to get 2, so negative 2 cubed, plus 3, negative 2 squared, minus 12, negative 2, minus 1. Alright, so when I do this, I'm going to get, let's see here, looks like 16 plus 12, which is 28, plus 24, which is 52 minus 1, which is going to give me 51. So I'm going to have a critical point at negative 2, comma 51. Hopefully I did my math right there. Okay. Actually, this should be right. Negative 16. I'm questioning my math now. 12. That should be a 24 and a minus 1. Yeah, I didn't think that was right. You're going to get negative 4, 20. You should get 19. That's probably still not right, but we're just going with it. Please let me know if that's not correct. I can always get a calculator and figure it out. For a 1, just plug in a 1. It's a little bit easier. So you're going to get 2 plus 3, which is 5, minus 12, which is negative 7, minus 1 is negative 8. And you're going to get 1 comma negative 8. So these are my critical points. Okay? One thing that I did not do yet is if it's undefined, that's typically going to happen when you have a number over, or whatever, something over the denominator. And that's when you set the denominator equal to 0. That did not happen for either of these, but as we start going further in the unit, that will happen. So let's talk about just finding absolute extrema. So for absolute extrema, what you need to do is you need to find your critical points and your endpoints and test them. Endpoints are always given to you. Okay? So what I always do is I make an X and Y chart. I always put my endpoints in there, and then I'm going to start filling in the rest with my critical points. So how do I find critical points? Well, take the derivative and set it equal to 0. So y prime is equal to 12x to the third minus 12x squared. and it has a GCF of 12x squared. So I'm going to get x minus 1 equals 0. So when I set this equal to 0, I'm going to get x to equal 0 and x to equal 1. So those have to go into my chart as well. So the negative 1 comes from the 1 endpoint, 2 is from the other endpoint, 0 is from one critical number, and then this 1 is from the other critical number. So now I just need to plug it back into here. So when I plug it in, I'm going to get 3 times negative 1 to the fourth minus 4 times negative 1 to the third, which is going to give me 3 plus 4, which is 7. When I plug in a 2, I'm going to get 3 times 2 to the fourth minus 4 times 2 to the third. This is going to give me 48. Yeah, 16 times 3, 48 minus 32. So 48 minus 32 is 16. If I plug in a 0, this one's pretty simple. You're going to get 0 and 0. So you're just going to get 0, and I plug in a 1, I'm going to get a negative 1. Again, just plugging in 1. Those are a little easier. So I'm going to have a max right here. And this is going to be my, not my min. I don't know why I did that. So my max is at 16, and my min is actually going to be right here at 1. Negative 1. So it's, I'm going to have a max at 216, and I'm going to have a min at 1, negative 1. This work right here, this is sufficient enough. You don't need to write anything else for AP on a free response. You don't even need to write down these numbers right here. Do the chart, tell me which one's the max, which one's the min, full credit. Okay? So why don't you go ahead and try 4 on your own, so you might want to pause the video. I understand it's trig, but we need to get really comfortable with the trig. So go ahead and pause the video and try it on your own. Okay, so I'm going to do this. So I'm going to make a little table, my x and y table. My endpoints are 0 and 2 pi. And then I need to find my critical values. So let's take the derivative of sine, which is going to be cosine of x. And then that's it, because derivative 3 is 0. Set that equal to 0. Divide the 4 over. So when does cosine equal 0? You do need to know this. I only care about the numbers between 0 and 2 pi. There's an infinite amount, but I only care about between 0 and 2 pi. So it equals 0 at pi over 2 and 3 pi over 2. So I need to add those values to my chart. Okay, when I plug in a 0, sine of 0 is 0 minus 3 is negative 3. Plug in a 2 pi, I'm actually going to get the exact same value. Negative 3. When I plug in a pi over 2, sine is equal to 1 at pi over 2, so I'm going to get 4 minus 3, which is 1. When I plug in a 3 pi over 2, that's when we get a negative 1 value. So we're going to get negative 4 minus 3, which is negative 7. Okay, so max, min, that's all you need to do. That is all the work that is necessary for this. Okay, and just looking ahead, we're going to be doing a lot of stuff where it can be just finding critical numbers. So this will be the lesson afterwards. It's finding increasing, decreasing. It's really just finding critical numbers and going from there. So this is very, very important. So please, if you need to watch this video again, please do that, and then go ahead and work on the worksheet. Try to get all of that done if you can, so that way you can check your answers to make sure that we are all good. Okay.